Today's video will show a few examples of integration tests. Hello, I'm James Helfrich. Integration tests are an essential part of the testing process because it verifies that individually tested units of software work well together. This video will give 3 examples of how to create an integration test using a variety of different technologies. In our first example, we're going to create an integration test for a component that manages a credit card account in a personal finance software package. Assume the credit card class has been unit tested. Also, the transaction class has been unit tested and the date class has been unit tested. The credit card class is a derived class among with savings account and checking account, where the account is the base class. The financial program has a collection of counts through the composition. This integration test will verify the account reporting mechanism. Okay, we're going to do this in Python. And so because the integration tests use the unit test framework, the very first step is to use the unit test framework. Next, we're going to create the individual test. First, we have to set up our fixture by creating a credit card account. We're going to call this 1, 2, 3, 4, 5, 6. I'm not super original with my names. And then our individual test case will be called credit card report. Now we're going to have the same setup, exercise, verify, and we don't need a tear down in this case because we're going to rely upon the individual components or units to tear themselves down. Now, the big difference between an integration test and a unit test is the setup phase can be very complex as well as use public interfaces. Remember, the goal of an integration test is to use the individually tested units as they would be used in the program. So I'm going to create a date using the non-default constructor. I'm going to create a few transactions using the non-default constructor. I'm going to add them using the standard way to add them to my account. Add, add, add. Now, what am I going to do with my exercise? I'm going to first generate a report. Then I'm going to get the deposits and then get the withdrawals from our report. Now notice that generate report, get deposits, and get withdrawals themselves may call other functions. So there's not just 3, there may be a dozen or maybe 2 dozen individual functions or units being called during the exercise phase, which makes this distinct from a unit test. That's what makes it an integration test. Now, when I'm finished, I can either verify the state of the classes by directly accessing the member variables, or I can use the public interfaces. Now, since the whole point of integration test is to test the program as it will be used in the application, we always favor the public interfaces, which once again is in sharp contrast to a unit test. So I'm going to assert that my get balance is 140. I'm going to say there's 2 deposits. The deposits are T1 and T2. And I'm going to say there's exactly 1 withdrawal, and that withdrawal is T2. In a second example, I want to create an integration test for a program to manage lists. There are several types of lists: a to-do list, a grocery list, a Christmas list, and a bucket list. That program will have a collection of lists through composition. We are concerned about the to-do list. Our integration test will consist of a to-do list with 20 elements, 3 of which are checked off. Our integration test will build a list and call a display method, which will only show items which are not checked off. In this case, we're going to do this in Java. And once again, since integration tests use the unit test framework, we're going to start with that. Then we're going to describe our individual test. This is our to-do list integration test. And then the individual test case is display unchecked items. And once again, I use a setup, exercise, verify, and perhaps tear down, just like we do with a unit test. So what's my setup phase? Well, I'm going to create 20 new tasks, and I'm going to check off task 3, task 7, and task 12. Now observe that creating the to-do list, adding the task, creating the task, checking off, these are all the public interfaces of the classes that I'm exercising. And I want to exercise them in the authentic way in which they're used in the application. I don't want to directly set them with direct access to the member variables as I would a unit test. Now, in this case, my exercise step is trivial. I just wanted to get a display object. But that get display is probably going to call, what, a dozen different functions? Quite a few for sure. And then in my verify, I'm once again going to access the public methods to do so. There should be 17 items, but there should be exactly 3 unchecked items. Okay, in our final example, we want to create an integration test for a program that simulates a projectile motion in a 0 atmosphere environment. The program will simulate the motion of a lunar module attempting to perform a soft landing on the moon's surface. Okay, now the very first thing I need to do is make sure I got the math right. So I'm going to identify the correct answer that should be after 10 seconds of flight. And this is done by manually performing the calculations. Now, if this was done in industry, then I would ask my subject matter expert to perform the math for me, and then I would verify that my results are exactly the same. Now, in this case, we're using C++, so we're going to use a homegrown unit test framework. So I'm going to make a comment for my test case describing the math as it would be performed, and it's going to show me what the answers should be. Now, my test case is called coast and going diagonally, and I have my setup, exercise, verify, and tear down as usual. So I'm going to create a lunar module. I'm going to set its position and velocity and acceleration using public methods. And then my exercise step. Now, what I'm going to do is I'm going to go through 10 different seconds of flight. So I'm going to say coast 10 times with my given acceleration for 1 second. Now, this should be exactly the same as if I coasted for 10 seconds. In other words, we want to make sure that we got our coast done correctly. When I verify, I want to make sure that my position is what I expect it to be and my speed is what I expect it to be. And since it's correct, then we know that it works. This is example 3.6.1, .2, and .3 in the integration test chapter of the software design textbook.